On November 9th, 3I Atlas once again shook the sky. It continued to graze the sun, releasing an extreme surge of heat, as if challenging the very source of light that sustains the universe. 3I Atlas had passed perihelion many times before, but this time it flared 5 times brighter without losing even a single grain of dust or trace of vapor. A comet that shines without losing mass and motion so gentle, yet defying every law of gravity. All instruments recorded the same undeniable truth: it was accelerating, but no natural law could explain how. The deeper the analysis went, the clearer the contradictions became. Nickel surpassing iron, an orbit of absolute precision, light bending in the wrong direction. Every detail, every number, whispering of an object not born of nature but created with intention. The repeated collisions of 3I Atlas with the Sun left scientists in silence. Could something be about to happen to the universe itself? Let us continue to uncover the mystery of 3I Atlas in its most recent encounter with the Sun. Because perhaps this story does more than challenge humanity's understanding of the cosmos. It asks a question no one dares to answer. Are we truly alone in the endless expanse of space? The light of 3 Atlas once again swept across observatories, satellites, and the patient lenses of telescopes watching the sky. And when it reached its perihelion, the closest point to the Sun, the impossible happened. The comet brightened, not slightly but 5-fold. For astronomers, that number was not just a detail, it was a scream. A comet cannot do that without burning away a part of itself, without shedding vast clouds of vapor and dust that burst like a veil into the sunlight. Yet none of that appeared. No grand coma, no blazing tail. The light came, but the debris did not. It was as if the object had learned how to shine, without losing itself. Across observatories, the data synchronized. Spectrographs confirmed the rise in magnitude, the lack of thermal emission. Everything pointed toward a contradiction. If the brightening were natural, it would demand a loss of at least 13% of the comet's total mass. That is not a poetic number, it is an unavoidable one. It emerges from the balance between radiation surface area and escape velocity, a law of evaporation written in the fabric of thermodynamics. But the universe that morning chose not to obey its own law. So scientists found themselves at a crossroads. Either a massive cloud had somehow escaped every instrument, or the acceleration the strange push detected in its orbit came from something that did not behave like sublimating ice. In the months before, perihelion, 3I Atlas had moved as every rock should. 4,022 separate measurements from 227 observatories drew a perfect gravitational curve. Every line fit Newton, every vector obeyed the Sun. But after the close pass, the math broke. A non-gravitational acceleration appeared. Tiny but measurable. A push invisible, consistent, as if some small engine had awoken, correcting its path. Astronomers called it an anomaly. The public called it impossible. And somewhere between those two words lay a quiet truth: something had changed. If it were just ice, the gas should have burst unevenly, chaotically, a spray of random vents, spinning the nucleus like a wounded stone. Instead, the thrust of 3I Atlas aligned perfectly within the orbital plane. No vertical component, no erratic tumbling. Just a clean, deliberate vector aimed outward from the Sun. It was this precision that haunted Avi Loeb, a theorist from Harvard, known for his habit of asking forbidden questions. He calculated that if the observed acceleration came from natural outgassing, then a vast fraction of the comet's mass must have vanished, and yet the object remained intact. He wrote simply, "Either the mass loss is invisible or the force is not sublimation. What could it be then? A reaction to sunlight through a material we've never seen, a pressure field emerging from an exotic compound, or a controlled thrust and intentional correction in trajectory? If the latter were true, something had switched on. Imagine that moment, a silent traveller after untold eons adrift between stars passing near our Sun for the first time. Its surface dark, metallic, scarred by radiation, now ignited not by fire but by command. A single pulse of acceleration so slight it would escape every human sense, yet enough to announce that it was awake. No one saw a flame, no one heard a signal. But the math itself whispered motion without cause. In cosmic investigation, that is the equivalent of a voice in an empty room. The notion, of course, is extraordinary. Science does not yield to imagination easily. It demands proof, repetition, prediction. but sometimes the data opens a door that reason hesitates to walk through, and beyond that door lies the vast unknown where our instruments end and curiosity begins. If 3i Atlas truly exerted its own force, then it belongs to a class of motion we have never catalogued. Not ion propulsion, not radiation recoil, something subtler, an internal reconfiguration, perhaps a shift of mass within producing a net vector change. In physics that would require an intentional structure. A body capable of balancing internal stresses, conserving angular momentum, and responding to external energy. That is by definition a design. Yet even to think it feels like crossing a boundary. To suggest purpose where we expect only accident is to challenge the humility science teaches. Still, humility cannot silence the question itself. For a time, researchers resisted the idea. They recalculated trajectories, adjusted albedo coefficients, modified thermal models. Perhaps the comet's surface was unusually dark, absorbing heat differently. Perhaps there were hidden vents on the sunward side, invisible to our telescopes. Each explanation brought a sigh of relief and another inconsistency, because no model, no matter how elegant, reproduced the data entirely. The acceleration remained, the brightening refused to fade, and the surface polarization negative extreme violated the scattering laws known from any cometary dust. The numbers were not wrong, they were simply uninvited. One could imagine 3i Atlas as a mirror held up by the cosmos itself, reflecting not our light but our limits. For centuries, humanity has named the anomalies it could not explain fireballs, mistaken for gods, auroras, mistaken for spirits, pulsars, mistaken for aliens. Each time the unknown shrank before the discipline of understanding. But now, in this age of precision, when every photon is measured, every orbit traced to decimals, the cosmos has found a new way to test us by offering us something that behaves correctly in all ways, except the ones that matter most. There is a peculiar beauty in contradiction. It is the birthplace of every theory, every rebellion of thought. When a comet brightens without burning, when motion emerges without cause, the universe is inviting us to look closer not with belief, but with wonder. And perhaps as the mathematicians debated and the telescopes adjusted, something else was happening. Perhaps this was less a discovery than a reminder that the cosmos is not a machine we have mastered, but a conversation we have barely begun. Somewhere across the quiet expanse, a traveller moved on silent, constant, unchanged. No one knows whether it will return, but in its wake it left a question so vast that even the stars seemed to pause before answering. After the first shock of that impossible brightening came the second, quieter revelation. A change in motion so small it would never touch the naked eye, yet so precise it broke the harmony of Newton's equations. For months before, perihelion, 3i Atlas, obeyed gravity with obedient grace. Its orbit was predictable, its parameters pure. But once it curved around the sun, the numbers began to drift, not chaotically, not like a natural jet of gas, but with intent. The instruments at Mauna Kea and Cerro Paranal caught it first a subtle deviation, a curve ever so slightly shallower than expected. When plotted across 4,000 data points, the offset became undeniable. Something was pushing the comet away from the sun with an acceleration roughly 1,000th of Earth's gravity. In human terms, that is the pressure of a feather, yet in celestial mechanics it is thunder. Normally such a drift would be blamed on outgassing. As frozen volatiles sublimate, they act like natural thrusters, throwing vapor into space and nudging the nucleus forward. But this time the direction was too clean. The vector lay perfectly within the orbital plane, its angle to the sun constant through each measurement window. No wobble, no torque, no random spin. That alignment suggested something far more deliberate, a thrust governed by geometry, not chaos. Avi Loeb's models gave the paradox a voice. If the push came from sublimation, then the comet should have lost more than 13% of its mass. Its albedo should have dropped its surface, should have vented plumes of vapor bright enough to stain the spectrum. Yet no plume appeared. The mass was still there. The brightness somehow was still rising. Either our telescopes had collectively missed a vast exhalation of gas, or the force had another origin entirely. In lectures and late-night panels, scientists debated the possibilities. Some invoked exotic ices, supervolatiles that vaporize at temperatures close to absolute zero. Others imagined microfractures on the surface releasing bursts of heat in timed sequence. But every new model required one more coincidence, one more unprovable assumption. The further they reached, the more the data resisted. So Loeb framed the puzzle differently. What if 3i Atlas did not react to the Sun but responded to it? What if the energy was absorbed, converted, redirected? A radiation pressure sail made of layered nickel compounds could in theory produce such a steady acceleration. The ratios of nickel to iron observed by spectroscopy seemed inconveniently to fit that profile. No one dared call it artificial not yet, but the equations left the door ajar. Even within that hypothesis, the mind rebels. To imagine a structure capable of steering itself is to cross from observation into intent. Yet every field has its moments when numbers whisper of something beyond habit. When Voyager 2 left the heliopause, it carried our questions into silence. Perhaps 3i Atlas carried silence back. At the observatories, technicians described the motion as too smooth. There were no micro jumps, no thermal oscillations, no trace of rotational decay. One analyst compared it to a satellite performing a gravity assist with full course correction. Another wrote in the margin of a report, "If this is outgassing, it's the most disciplined gas I've ever met. Still, science must breathe through skepticism. The data could be incomplete, the sensors could have drifted, the comet could have masked its venting behind its own shadow. All were valid, all were possible. Yet somewhere under those measured disclaimers an unease began to take root. The feeling that the universe was showing us not an error, but an instruction. For if a rock can steer, if a comet can alter its path with precision, then the boundary between the inert and the intentional has already been crossed. That single truth delicate as the acceleration itself hung in the air of every observatory. And while no one said it aloud, each scientist who ran the numbers again felt it the same way, a quiet, inexorable realization that we might be watching a traveller, not a relic. There is a moment hidden within the silence of mathematics when motion becomes intent. For 3i Atlas, that moment came not in a burst of light, but in the smallest deviation imaginable, a subtle, graceful defiance of gravity's command. In the raw data, it appeared as a shift of decimals, a curve fractionally shallower than Newton would allow. But in the language of physics, that curve meant one thing: something had awakened. For months leading up to its perihelion, 3i Atlas moved like a perfect equation. Each positional reading from more than 200 observatories aligned within the precision limits of the models. It was a silent, obedient body until the instant it wasn't. After it swung around the Sun, its orbit no longer matched predictions. The deviation was small, 1 part in 10 million, but it grew consistently with every measurement. It was as if an invisible hand had reached out and adjusted its path by design. Scientists called this change a non-gravitational acceleration, a phrase that describes the phenomenon while politely ignoring its cause. To an ordinary comet, such an effect would come from jets of vapour, unevenly erupting from the sunlit face. But every analysis of 3i Atlas showed a vector too disciplined, too stable. The direction of thrust aligned precisely with its orbital plane, a plane shared by the major planets. It was an alignment so perfect it defied the chaos of nature. Avi Loeb once wrote that nature, when left to itself, produces elegance but not precision. Precision implies decision. That thought lingered over every discussion, unspoken yet unavoidable. The acceleration seemed to switch on after the comet reached perihelion, as though responding to the Sun's energy not by reaction, but by recognition. There were whispers among the research teams. What if 3i Atlas had waited? What if it had been dormant, conserving energy across light years, and the proximity to our star served as its signal to awaken? The hypothesis was dismissed publicly, but privately no one could fully erase it. The data had the rhythm of command activation, followed by control, followed by retreat. In the recordings from the European Southern Observatory, a slight phase change appeared in the reflected spectrum, like a shimmer that lasted less than 2 hours. It wasn't enough to be called emission, but it was something, a change in reflectivity that hinted at movement beneath the surface. Perhaps it rotated a shield, redirected panels, adjusted orientation. These are mechanical interpretations, but they fit the numbers far more elegantly than random venting. Imagine this through the calm of cosmic silence, an object older than history, its body forged in alien light, crossing the solar plane for the first time. It absorbs radiation, translates it into a motion so subtle that only mathematics can see it. Then with one quiet pulse, it shifts its path, not to escape, not to hide, but simply to continue. The act itself carries no sound, no signal, no declaration. Only the numbers tell the story, and they speak of control. If that control exists, it implies awareness, or at least architecture. To build something that can awaken after eons demands an understanding of durability beyond any human engineering. A system must withstand dust impacts, cosmic rays, micrometeor collisions, and yet still respond to sunlight as if obeying a stored command. It would need layers of protection, memory, and function, a vessel designed not merely to travel, but to wait. The thought is difficult to hold without drifting into wonder. Could there exist civilizations so ancient that their technology has outlived their creators, machines travelling endlessly, carrying no message but endurance itself? The cosmos could be full of them, silent and inert, until gravity and sunlight awaken them for brief moments of movement. We might not be seeing intent at all, only the echo of a design that persists beyond time, and still the image is hard to resist. A traveller reaching perihelion, its sensors, warming its systems, remembering. No flames, no noise, just motion, resuming deliberate and exact. A machine performing its task, whatever that may be, without audience or command. After perihelion, 3i Atlas continued on its altered trajectory, fading back into darkness. The acceleration persisted for weeks, steady and calm before slowly diminishing. Some said the force ceased once it had adjusted to its course, as though it had completed whatever correction it needed. Others said the loss of thrust was proof of an internal failure, a dying system spending the last of its stored energy. Both theories fit, and neither explained everything. When the final observation came in, the comet's light was faint, its spectrum nearly featureless. But for those who had watched its brief defiance, that faintness felt more like withdrawal than decay. The data told a story not of chaos but of purpose, restrained, minimal, efficient. And in that efficiency, scientists saw the most human of patterns choice. Perhaps that is why 3i Atlas captured imagination more deeply than any other comet. It reminded us that even silence can carry meaning, that precision itself may be a language, and that not all awakenings come with noise or flame. Sometimes the universe stirs softly, and in that subtle motion, it whispers the most profound question of all: who or what still remembers to move? When the first phase of analysis concluded, the astronomers did not speak of mystery. They spoke of geometry. They spoke of the way 3i Atlas moved, not like a fragment of ice set adrift, but like a body aware of its own direction. The more data they plotted, the clearer the shape became, a vector born from order, not randomness. Across hundreds of observation logs, one pattern held constant. The non-gravitational acceleration pointed directly away from the Sun, hugging the orbital plane with uncanny precision. Not a fraction of a degree above or below, not the slightest hint of torque or roll. The thrust behaved as though it had been programmed to align with the Sun itself, a clean mathematical choreography. To understand why that alignment matters, one must recall what chaos looks like. Natural comets vent gas from irregular surfaces. As sunlight warms different regions, the pressure jets fire in unpredictable bursts, sending the nucleus tumbling. Each spin alters the jet's direction. Each jet alters the spin. It is a dance of imbalance, chaotic, temporary yet beautiful. But 3i Atlas refused to join that dance. The push it generated was steady, coherent, and silent. Instruments registered no flicker in its light curve, no indication of rotation instability. In dynamic simulations, its trajectory produced the same smooth arc that a guided craft would trace if it were correcting its path against gravitational drift. Every statistical test yielded the same conclusion: the odds of such consistency through random venting were nearly zero. Avi Loeb and his colleagues began to model the data through the language of vectors and control systems. The result resembled something engineers know well: vector thrust alignment. In this model, even a low-power propulsion source can achieve stability if it keeps the thrust vector locked to the plane of motion. The system corrects its own deviation over time, much like a satellite maintaining attitude during a maneuver. That idea that a comet might unconsciously mimic the logic of a spacecraft drew quiet fascination. No one wanted to say the word artificial, but the symmetry of the equations whispered it anyway. Some researchers proposed that the comet's surface might contain a reflective lattice, perhaps nickel, or another high-albedo metal, forming microstructures that naturally direct radiation in one dominant orientation. It would be an extraordinary coincidence of material science, but at least it stayed within the bounds of nature. Others saw something else. If radiation pressure truly caused the acceleration, then the reflectivity had to be nearly perfect, smoother than any rock, cleaner than any dust. The surface would need to act like a sail, catching the solar photons and converting them into motion. It would mean that the object wasn't just surviving sunlight, it was using it. To test this, Loeb's group reconstructed the force profile. The thrust aligned within less than 1 degree of the Sun's radial vector, a precision too fine for chance. Over millions of kilometers, the deviation never wandered. Every observation reinforced the same conclusion: this was motion under guidance. Whether that guidance came from physics or from purpose was a question the data alone could not answer. Yet even as they argued, the beauty of the phenomenon began to sink in. There was something almost poetic in watching a fragment of the cosmos move with the confidence of design. The telescopes followed it night after night, tracing its path like a signature written across the void. Each data point became a heartbeat, faint, distant, but deliberate. If this was natural, it meant nature had found a new way to write symmetry. If it was not, then humanity had glimpsed the first act of an intelligence that does not announce itself, but expresses its presence through precision. Either way, the laws of motion, once thought complete, now felt like the opening lines of a larger conversation. In the quiet control rooms under the red glow of monitors, the astronomers kept plotting. They knew they were watching something that should not happen, yet it happened anyway. Each curve of the orbit told a story, gravity calling, and some unseen hand answering. The geometry of motion had become geometry of intent, and in that intent, written across the mathematics, was a question that no one dared to utter aloud, because once spoken, it would no longer be science but revelation. For centuries, astronomy has found comfort in chaos. It is the signature of nature's honesty. Comets in particular are creatures of disorder, their surfaces scarred by impact, their cores riddled with frozen fractures. As they approach the sun, they awaken violently, exhaling vapor from fissures carved by ancient cold. The result is beautiful, unpredictable, and utterly untamable. No comet until 3I Atlas had ever shown restraint. Ordinary comets are inconsistent dancers. Their jets of gas erupt at random, spinning the nucleus like a coin on a table. The direction of their thrust changes minute by minute, driven by heat, by rotation, by luck. A typical comet behaves like an orchestra without a conductor sound, and fury arranged by accident. When the gas vents unevenly, it adds small jerks to the orbit, minor deviations that fade as the outburst subsides. This chaos is not a flaw, it is the heartbeat of nature's entropy. But 3 Atlas did not follow that rhythm. Its behaviour was calm, deliberate, and to some deeply unsettling. The thrust vector remained steady for weeks, never swaying from its alignment with the sun. The torque expected from random outgassing was absent. The spin rate remained constant within measurement error. Where other comets roared with thermal irregularity, 3I Atlas whispered with precision. The difference is not merely poetic, it is physical. Random jets produce oscillations in both speed and brightness. Yet the light curve of 3I Atlas was smooth, almost engineered. Every burst of brightness corresponded to a controlled increase in acceleration, like a system responding to input, not coincidence. It was as though the object knew how to balance itself against the solar wind. This contradiction sent theoreticians deep into revision. Some proposed a layered nucleus with concentric shells that released gas evenly across the surface, an improbable yet comforting scenario. Others invoked magnetized grains, suggesting that the comet's rotation might align with the interplanetary magnetic field stabilizing its outgassing. But the required alignment precision was absurd within a fraction of a degree across millions of kilometers. It was possible, yes. But probability and possibility are different languages. At the Harvard-Smithsonian Center for Astrophysics, a small team simulated thousands of comets under varying venting conditions. None reproduced 3I Atlas's stability. When they plotted the results, the difference was not subtle, it was a void. Nature offered chaos, the comet offered control. Between the two, the models broke down. It was then that the conversation shifted from why to how. If such control existed, it demanded a mechanism. Radiation pressure alone was too weak. Continuous venting would have caused measurable loss of mass. Some unknown process had to be converting energy into motion, a feedback system balancing thrust and orientation. It did not need to be sentient, it only needed to be built. The phrase self-regulating body appeared in one paper buried in a paragraph meant to be ignored. The author withdrew it in revision, fearing sensationalism, but the idea remained alive in discussion rooms. A self-regulating comet would be a new class of object, a structure that interacts with sunlight like a sail, not through reaction but through geometry. Its surface would have to consist of compounds that reflect and absorb light in selective ratios, creating thrust in one direction. It would act as both engine and stabilizer. In theory, such a body could exist not as an alien probe, but as a remnant of cosmic engineering, perhaps a byproduct of planetary debris refined by stellar radiation. Over eons, collisions and erosion could shape fragments into balanced responsive forms. The idea blurred the boundary between natural formation and intelligent design. The universe, after all, is the oldest engineer of all. Still, the precision of 3I Atlas continued to trouble those who studied it most. A natural object can mimic design once, but not for months. And when the same measurements repeated acceleration, constant vector pure, the numbers themselves began to sound like intention. A quiet debate grew in the scientific community. Was this the universe showing us a new kind of order, or was it reminding us that order itself might be evidence of something greater? Every field meeting ended the same way, with silence. No one wanted to be the one to say it. Control in itself is not proof of purpose, but it is proof of potential. And somewhere between those two lies the question 3I Atlas left behind, a question that lives between science and faith, between the chaos we know and the control we fear to acknowledge. As it glided through the heliocentric void, its surface still gleaming faintly from perihelion light, the comet carried with it a paradox that would not fade a natural body that moved like a thought. And perhaps in that strange equilibrium, it revealed something essential, that control and chaos are not opposites but partners in the language of creation. Among all the patterns that defined 3I Atlas, none disturbed astronomers more than the light that moved the wrong way. When the first high-resolution images from the Hubble Space Telescope arrived in July, they revealed something small but unmistakable: a narrow jet of material, a faint thread of light extending toward the sun. That detail might seem innocent to the untrained eye, a smudge against the brightness, but to those who know the physics of comets, it was a violation. Every comet's tail points away from the sun, always. That rule is carved into radiation pressure itself. Solar photons and charged particles push the dust and gas outward, sculpting the familiar arc that sweeps into the dark. The sun repels, it never attracts. And yet in those photographs, the jet of 3I Atlas reached back almost as if defying the light that had just awakened it. At first, the team thought it was an imaging artifact, a misalignment between exposures. But the feature appeared again, faint, steady, unchanged across multiple orbits of Hubble's sensors. The angle was not random. It was precise within 2 degrees of the sun's vector, a jet that pointed toward the light. To produce such a configuration naturally would require an improbable coincidence, a vent positioned perfectly on the shadowed hemisphere of the nucleus firing gas at high velocity, while the comet spun slowly enough to hold orientation. Thermal modelling showed that any normal rotation period would smear the jet into a blur. But this one remained sharp. The comet seemed to maintain its direction as though locked in place. The simplest answer that we were seeing a controlled exhaust hovered unspoken in every meeting. A vent that faced the sun could act like a steering thruster correcting orbit, while compensating for radiation pressure. The idea was too deliberate, too human. Yet the geometry was undeniable. If this were outgassing, it was a form of propulsion we had never observed before, thrust against the sun, the very source of energy that powered it. It was as if the comet had turned the laws of reflection upside down, using light not to flee but to anchor itself. In theory, such an anomaly could result from the interaction of magnetized dust and plasma winds. A charged particle field might bend the direction of ejected material back toward the sun under rare conditions. But the magnetic intensity required would exceed the interplanetary average by several orders of magnitude. The solar wind is not that strong. The comet is not that conductive. And still the data persisted. One astronomer called it the most disciplined chaos ever recorded. Another said quietly, "If this is natural, it is nature pretending to think." The jet's spectral signature showed no sign of cyanide or carbon, the normal fingerprints of cometary gas. Instead, it bore faint traces of metal ions, nickel and sodium, shimmering at wavelengths, more typical of vaporized alloys than ice. When modelled, the emission curve fit a profile closer to molten nickel dust, a kind of reflective plume that could under sunlight generate a photonic recoil force. A reflective jet, a jet made to shine. This observation linked back to the earlier puzzle of 3I Atlas's composition, its unusual nickel to iron ratio, its low water content, its polished reflectivity. If this was coincidence, it was one with too many parts. If it was a pattern, then the pattern had purpose. And yet science cannot survive on awe alone. the teams at ESA and NASA continued to test every natural scenario. One possibility remained the Yorp effect, a subtle torque caused by asymmetric heat emission. Over time, it can alter an asteroid's spin or tilt. Perhaps 3I Atlas was experiencing an extreme version of it, but to generate the observed thrust, the thermal gradient would need to be hundreds of times stronger than known physics allows. The comet's surface would have to act as a near-perfect mirror, redirecting sunlight with precision. In that moment, physics itself seemed to hesitate, because what they were seeing was not merely a body illuminated by the sun, it was a body interacting with light as if it understood it. In simulation, labs' models tried to recreate the event. None succeeded. A natural comet could not maintain such consistency. A random vent would never sustain such symmetry. Slowly, reluctantly, the discussion turned to geometry again, to the possibility of a structure hidden beneath the dust guiding the motion. If such a structure existed, it could mean one of two things. Either we had discovered a form of natural organisation far beyond what we thought possible matter-learning order through radiation, or we were witnessing a relic of something once engineered. No one dared say which was more extraordinary. And as the last images of the jet faded into the glare of the sun, the question lingered like an afterimage. What kind of traveller throws its light backward, not away from the star, but toward it, as if returning a signal? If motion had challenged physics, composition now began to challenge chemistry. When the spectral data of 3I Atlas was first decoded, what emerged seemed almost impossible. The elemental ratios were backward. The comet contained more nickel than iron. That single inversion may appear trivial to a lay observer, but to astronomers and metallurgists it was like finding ice that burns. Throughout the solar system, from meteorites to planets, the abundance of iron surpasses that of nickel. The ratio is a fingerprint of stellar evolution, the direct child of nuclear synthesis inside massive stars. During supernova collapse, iron forms in the last stages of fusion, while nickel decays into it over time. The pattern is so consistent that every rock, every asteroid, every speck of dust in the solar record carries the same signature iron, dominant nickel subordinate. But 3I Atlas broke that rule. Its spectral lines revealed a different origin story, one that should not exist. In its reflected light, the peaks at 341 and 358 nanometers burned stronger than iron's baseline, and when calibrated against known reference spectra, the numbers inverted. Nickel exceeded iron by almost a factor of 2. The chemistry of creation had been reversed. For days, researchers doubted the data. Perhaps the calibration was off, or solar contamination had distorted the readings. But repeated measurements from the Subaru telescope and the Lowell Observatory confirmed the result. Each new observation made the anomaly firmer, not weaker. The instruments were telling the truth. The universe apparently was not. Nickel in abundance is not a trivial matter. It is one of the most resilient metals in the periodic table, resistant to oxidation, tolerant of radiation, capable of maintaining structure under extreme heat. In industry, it is the cornerstone of alloys designed to survive plasma engines, reactor walls, and interplanetary re-entry. If nature had indeed produced a body dominated by nickel, it would have been forged in temperatures higher than most stars could sustain, or built by someone who understood why that metal must endure. There was something eerily deliberate about it. A body meant to cross interstellar space for millions of years would need to be both reflective and stable, resistant to corrosion, slow to decay. Nickel would serve that purpose perfectly. Its spectral albedo would protect it from constant bombardment, while its mechanical strength would preserve its shape against micrometeor impacts. The more scientists analysed the data, the more the material composition looked less like coincidence and more like selection. But speculation walks a fine line, and no scientist was willing to cross it openly. Instead, they invented new hypotheses, safer ones. Perhaps 3I Atlas was born in the furnace of a supernova remnant, where nickel was produced in overabundance before the heavier elements could form. Or perhaps it came from a binary system where repeated accretion stripped away lighter compounds, leaving only the metallic heart behind. These explanations soothed the fear of intent, but not the curiosity. As the models multiplied, one fact persisted: such ratios were statistically improbable. Out of tens of thousands of known comets and asteroids, none matched this inversion. Even the most exotic interstellar visitor before it, Oumuamua, had shown no such anomaly. Whatever 3I Atlas was made of, it came from a place unlike any known region of the Milky Way, or from a process that no one yet understood. In the silence of that realization, something subtle changed in tone among the researchers. The language of reports began to shift from object to structure, from body to composition. Even the cautious papers that rejected the idea of intelligence began to use phrases like engineered resilience or metallic uniformity. The data itself was pulling them toward a new vocabulary. There were moments late at night when the younger astronomers spoke more freely. They would sit in the dim control room surrounded by screens that shimmered with spectroscopic lines and whisper about the implications. Could a fragment of engineered matter drift across the galaxy long after its makers were gone? Could the laws of physics preserve artifacts the way geology preserves fossils? The thought was both comforting and terrifying that the cosmos might not be empty of creation, but full of its remains. Still, the official stance remained cautious. Every scientific sentence ended with the same quiet disclaimer: further observation required. Yet in private, the conviction was spreading that Nickel had spoken where words could not, and that in the metallic shimmer of 3i Atlas lay the first trace of something crafted to last forever. When the chemical analysis of 3i Atlas deepened beyond metals, the picture grew even stranger. If the overabundance of nickel had rewritten the laws of formation, the next discovery erased what little remained of familiarity. The comet was almost dry. Typical comets, whether from the Oort cloud or the Kuiper belt, are half water by mass. Their luminous tails are born of ice sublimating into gas, a transformation so violent it can be seen from millions of kilometers away. In that vapour, the signature of cyanide CN has been the most faithful companion of cometary spectra since the first telescopes learned to dissect light. Cyanide is ubiquitous. It is the fingerprint of the early solar system, the molecular ghost of cosmic chemistry. But in 3i Atlas, cyanide was gone, vanished. Across dozens of observations, the cyanide emission lines, those fragile markers around 388 nanometers, were missing, replaced by a clean metallic silence. There was a faint trace of carbon monoxide, a whisper of sodium, but nothing resembling the organic richness of a normal comet. The ratio between nickel and cyanide, in fact, was higher than in any recorded celestial object. It was not the ratio of an ice body, it was the ratio of an artifact. At first, researchers assumed an instrumental fault. Perhaps the detectors had saturated under the glare of the sun, washing out the lines. But the absence was consistent across instruments. Hubble Subaru and the Very Large Telescope all agreed. The data held. 3i Atlas contained almost no volatile compounds. It was not a snowball, it was something else. What replaced water and cyanide was equally telling. The residual spectral features hinted at oxides of nickel and silicon materials that form not in the cold, but in heat. They are the compounds of fabrication, the skin of machines, the shell of engines. In engineering, nickel oxide resists corrosion, reflecting light and dispersing radiation. It endures. To find it in an interstellar object was to glimpse the possibility that endurance had been the goal all along. A few bold voices began to ask what if the dryness was intentional. A dry surface would never erupt, never fracture, never lose its mass to sublimation. It could cross countless systems without changing shape. Water for a vessel meant to travel the void is not a resource, it is a liability. To retain integrity, one must give up volatility. The comet's very sterility might have been its protection. In a closed discussion at the European Southern Observatory, one scientist described the composition as the signature of preservation, not evolution. Another compared it to a coating an exoskeleton made to survive stellar heat. Both remarks were struck from the final transcript, but in their removal they spoke louder. Still, the idea of design remained taboo. The more acceptable theory was that 3i Atlas came from an ancient radiation-baked region, near a dying star, a place where water and organics had long since boiled away. It could be the shard of a planet stripped to its metallic bones, wandering through the galaxy like the fossil of a world. That version comforted the community. It explained the anomaly without invoking intention. And yet, there were subtleties in the data that resisted even that explanation. The water content of 3i Atlas was not merely low, it was too precisely low, around 4% by mass, consistent across every measurement window. Natural bodies fluctuate, they vent unevenly, they lose mass over time. But 3i Atlas remained constant, as if its composition were regulated like a system maintaining equilibrium. Such uniformity suggests not accident but architecture. In thermal models, a body with precisely that dryness would balance heat absorption and emission, perfectly reflecting just enough radiation to prevent melting while absorbing enough to sustain motion. The ratio was not random, it was optimal. Some scientists quietly wondered if they were looking at a form of passive thermal regulation, a self-cooling design. A layer of nickel oxide could serve as both shield and radiator, dissipating heat without mechanical effort. A vessel made this way would never overheat, never spin out of control. It would glide through sunlight the way a fish moves through current, adjusting by physics alone. In the long hours of analysis, as spectra turned into numbers and numbers into models, the comet began to feel less like a wanderer and more like an object built with purpose, a relic of balance between endurance and motion. Perhaps not alive, not intelligent, but functional. And yet every theory that flirted with that idea carried a quiet dissonance. For if 3i Atlas was constructed, it would not just be a machine, it would be an ancient survivor crossing eras older than language. It would mean that creation somewhere had outlived its creators. In its dryness, there was a kind of perfection, not absence but choice. The void between its molecules was not emptiness, it was preservation. It had nothing left to evaporate, nothing left to lose, and maybe that was the point. To last forever, one must surrender the things that fade. Light is the oldest messenger in the universe, and yet it still finds ways to surprise us. When sunlight touches a comet's dust, it scatters, bending and twisting through the grains, splitting into patterns of brightness that tell us about size, texture, and composition. Astronomers measure this scattering as polarization, the angle at which light waves align after reflection. For centuries, this has been one of the most reliable tools in astrophysics. Polarization obeys rules as old as optics itself. And then came 3i Atlas. The measurements began routinely. Using polarimetric filters, observers at the Subaru telescope compared the reflected light of 3i Atlas to known calibration targets. They expected to see the usual range, a mild positive polarization, somewhere between 2 and 7% indicating dust particles scattering sunlight forward. Instead, the readings plunged negative. The numbers were not just off, they were inverted. The polarization was extremely negative, far below anything observed in a natural comet. Its magnitude defied scattering theory, implying that the light had been not merely reflected but manipulated, redirected in a way that absorbed its linear component and re-emitted it at a reversed phase. In plain language, 3i Atlas was bending light in the wrong direction. At first, the team thought the instruments had failed. They recalibrated the sensors, replaced filters, repeated the process on reference stars. The error persisted. No matter how the instruments changed, the 3i Atlas refused to behave like a dusty rock. Its reflected light was coherent, polarized opposite to expectation, like a metallic mirror, not a cloud of particles. Such a surface requires an order of precision nature rarely grants. For negative polarization to occur at that scale, the reflecting layer must be composed of submicron structures, arranged in patterns that cancel certain wavefronts of light. It's a behavior found in engineered materials, nanostructured coatings, artificial lattices, metamaterials, not in random cosmic debris. The effect is like that of stealth technology. Light doesn't bounce off, it flows around. That realization spread through the research community like a quiet ripple. If 3i Atlas possessed such a surface, it wasn't just surviving sunlight, it was controlling it. The surface acted as both mirror and shield, absorbing scattering and modulating radiation with mathematical precision. Some models suggested a hexagonal crystalline pattern. Others invoked layered compounds of nickel oxide and carbon silicate structures that, if manufactured, could have been designed to endure billions of years of exposure. The probability of this forming naturally was less than 1 in 1,000. But the human mind resists that kind of improbability. So scientists did what they always do when the numbers begin to whisper the unthinkable. They built new possibilities. Perhaps one theory said the negative polarization came from particle interference in a surface of ultrafine grains. Maybe each grain was coated in reflective frost, forming microcavities that bent light back upon itself. But that model failed to reproduce the stability of the signal. The negative polarization of 3i Atlas did not fluctuate with distance from the Sun. It remained constant and unchanging property as though written into the structure itself. The alternative was more daring, that the effect was deliberate. In this scenario, the surface of 3i Atlas might function like an adaptive shell, not to disguise itself but to endure. By controlling the angle of reflection, such a material could minimize heat absorption, reducing temperature stress across its body. It could travel through sunlight without melting, like a ship moving beneath a wave instead of against it. In the vacuum of interstellar space, such design would be the difference between survival and disintegration. Even among the cautious, the idea had gravity. The astronomers called it the mirror paradox. If the surface truly manipulated light, then 3I Atlas was not a comet at all, but a construct, a shell whose purpose was protection. And yet there was no sign of energy emission, no signal, no motion beyond the faint non-gravitational push already measured. It was as if the object had been built not to act, but to endure. That notion drew them back to the metallic composition. Nickel and iron in reverse proportions, a body almost free of volatiles, a smooth reflective shell with optical properties beyond nature. Piece by piece, the comet's portrait was taking shape not as a frozen relic of creation, but as a survivor of something lost. If the polarization were truly impossible, then perhaps it was not a mistake of light, but of our understanding. After all, physics does not break. It waits to be expanded. Every violation is an invitation. When the first pulsar was discovered, it was called an alien signal until it became a new class of star. But sometimes the reverse may be true. What we call a comet may be the remnant of an idea. The data still stands untouched, unchanged. The negative polarization remains the most extreme ever measured, the light of the sun itself, mirrored through something that should not exist. And so, under the endless quiet of the night sky, 3I Atlas continues to drift, reflecting the impossible, a mirror not of the cosmos, but of the boundaries of human certainty. For centuries, science has thrived on the predictable. The universe, vast and often violent, still obeyed a comforting pattern. Where the same forces act, the same results follow. We learn to name these regularities, laws, constants, principles, as if nature itself were a machine of infinite precision. But every so often something arrives that refuses to fit, and when it does, we call it a black swan. The term borrowed from philosophy describes the improbable, the event that should not exist yet does. In the story of 3I Atlas, the black swan is not one anomaly but many. Each by itself could be dismissed as coincidence. Together they form a chorus of defiance. The data told the tale. A comet that brightened fivefold without shedding mass. A jet that pointed toward the sun. A surface richer in nickel than iron. A body almost devoid of water and cyanide. A polarization curve inverted beyond theory. Each thread improbable, the tapestry impossible. When the numbers were combined, the probability of all these traits occurring together by chance dropped below 1 in a billion. And yet here it was, streaking through our solar system, observed by hundreds of telescopes, undeniable and calm. In one late-night meeting at the Harvard-Smithsonian Center for Astrophysics, a researcher wrote on the whiteboard, "If it behaves like nothing known, maybe it is nothing known." No one answered. The silence that followed was not skepticism, it was unease. Because that sentence, unspoken for decades, had begun to echo again. Maybe we're not just looking at a comet. The black swan logic is cruel in its simplicity. When every natural explanation requires stacking coincidences higher and higher, at some point the tower collapses under its own improbability. To preserve the natural model, one must multiply assumptions. To question it, one needs only to consider intent. Avi Loeb once phrased it differently. Nature can produce miracles, but it rarely does them all in one object. His argument wasn't faith, but probability. If a coin lands on its edge once, it's strange. If it does so 10 times in a row, you stop calling it chance. Yet even Loeb's boldness had limits. The scientific establishment recoiled from his conclusions, not because they were unreasonable, but because they were unsettling. To accept that 3I Atlas might not be natural would force us to widen our definitions, to admit that intelligence may leave fingerprints even when the hand is gone. And still, there is a discipline to skepticism. The black swan theory demands humility. Extraordinary claims require extraordinary evidence. So researchers dissected each anomaly one by one, like surgeons separating nerves from bone. Could the brightness be due to forward scattering? Possibly. Could the nickel inversion come from an unusual stellar nursery? Conceivably. Could the polarization result from submicron dust interference? Theoretically. Each answer held just enough plausibility to keep the paradigm alive, but the cost of each justification grew heavier. The models became baroque layers upon layers of exception tuned to explain away the discomfort. By the end, the equations looked less like physics and more like theology. At that point, some began to see the deeper pattern not in 3i Atlas itself, but in us. Humanity had always preferred complexity to confession. When the data whispers this should not exist, we build castles of explanation to protect our peace. Yet every century a new object arrives to tear them down. Perhaps that is the true function of the black swan, not to break science, but to remind it to breathe. In the archives of cosmic observation, the name 3 Atlas now sits beside Oumuamua. The pulsars once thought to be alien signals, the cosmic microwave background once mistaken for pigeon droppings. Each was an interruption, a distortion, a flash of something beyond expectation. Each forced science to evolve, but this time the interruption feels different, more deliberate, less like noise, more like punctuation. Maybe 3i Atlas is not a message, maybe it is a question written in nickel and silence thrown across the galaxy for anyone curious enough to look closer. A reminder that our models are only mirrors, and sometimes the reflection stares back. In celestial mechanics, coincidence is the rarest illusion. Every trajectory, every tilt and curve follows laws that stretch back to the birth of the solar system. Randomness exists, but even it has structure, a probability field written in gravity. Which is why the orbit of 3i Atlas troubled astronomers most of all. It was wrong in the most precise way possible. Most interstellar visitors cut across our planetary plane at sharp angles, plunging through the solar system like stones through water. The ecliptic, the thin invisible disk where all planets revolve, occupies a narrow slice of space. The odds that a foreign body would align with it are almost negligible. Statistically, less than 1 in 500 such objects should do so. Yet 3i Atlas, arriving from the abyss between stars, traced a path nearly parallel to that ancient plane, within 5 degrees of perfect alignment. To the casual observer, that number may seem trivial, but in celestial geometry, 5 degrees is an act of precision. It is the difference between a wanderer and a visitor, between accident and arrival. As orbital models refined, another subtle pattern emerged. The comet's perihelion, its closest pass to the Sun, occurred at a moment of perfect concealment. On October 29th, when 3 Atlas reached its point of greatest brightness, the Earth lay almost exactly behind the Sun from its perspective. For 2 crucial days, no observatory on our planet could see it directly. The Sun's glare, a shield of light, erased the object from view. To astronomers, this timing was maddening. Every other interstellar object had announced itself with enough lead time for continuous observation. But 3i Atlas had chosen, or happened, to pass through the one corridor of invisibility in the inner solar system. The odds of such a coincidence when multiplied with its orbital alignment dropped below 0.2%. It was as if the universe had turned its head for just a moment, and the object slipped past unnoticed. The calculations deepened the unease. A retrograde orbit moving opposite the planets would normally send a comet diving steeply through the solar system's plane. Instead, 3i Atlas glided nearly flat, threading the gravitational seams between Earth, Venus and Mercury with unnerving precision. The path minimized encounters, avoided perturbations and reduced detectability. In mission design, such a trajectory is called stealth insertion. In nature, it is called impossible. One simulation run by a team in Prague traced potential entry vectors from interstellar space. Out of 10 million randomized trials, only 7 produced an orbit with comparable characteristics, and all 7 required pre-existing velocity adjustments as if something had aimed. The phrase guided entry began to appear in internal memos, always followed by caveats. The scientists spoke carefully, cloaking speculation in language of probability. But beneath the numbers, the implication grew heavier. If this were a natural object, it had not just entered our system, it had navigated it. A few astronomers proposed an alternative. Maybe the orbit was shaped by gravitational resonance from an unseen encounter long ago, a dance with some rogue planet or passing star that left its path finely tuned. But even that explanation struggled to account for the exactness of its alignment with the ecliptic and the uncanny timing of its perihelion. It was as though 3i Atlas had been scheduled a train arriving at the only moment no one was watching. For months, the mystery of its invisibility window haunted researchers. What had happened during those 48 hours when the object vanished behind the Sun? When it re-emerged, its brightness had changed, its tail reoriented, and its acceleration had begun. The phase shift in its light curve suggested surface restructuring or activation. That word activation entered the discussion reluctantly, a term borrowed from engineering, not astronomy. But no natural comet activates. They sublimate, they fragment, they decay. They do not awaken. If it were truly active, then the alignment and timing were not accidents at all, but components of a plan, a maneuver executed within the constraints of physics optimized for concealment. It would mean 3I Atlas had not only entered the solar system intentionally, but had used the sun itself as camouflage. And yet to believe that is to face a far greater paradox. Why would any intelligence send such an object slow, silent, lifeless, instead of something visible, communicative, alive? Unless the purpose was not communication at all, but endurance, observation, or perhaps remembrance. Some began to see it differently, not as a ship, but as a relic on autopilot following instructions older than civilization. A trajectory repeated for eons through system after system seeking. Nothing in particular, just continuation. In that sense, its precision might not be evidence of intent, but of memory. A pattern encoded in orbit, a path once calculated and left adrift forever. A ghost following the mathematics of its own creation. Either way, deliberate or fossilized, the orbit of 3I Atlas forced us to confront the same discomfort. When the universe writes something this precise into its equations, we are left to ask who or what first held the pen. In the archive of human curiosity, few mysteries have endured like a whisper from the summer of 1977, the so-called wow signal. A narrowband radio burst lasting exactly 72 seconds detected by the Big Ear Observatory in Ohio. Its origin, the constellation Sagittarius near the galactic plane. Its frequency, 1420 MHz, the spectral line of neutral hydrogen, the universal language of the cosmos. It never repeated. It never explained itself. All that remained was a handwritten note, one word circled in red ink, wow. For nearly half a century, astronomers debated that anomaly, a ghost in the static, a mathematical breath from somewhere unseen. Then almost half a century later, something else appeared, from nearly the same direction, 3I Atlas. When trajectory analysts projected the path of 3I Atlas backward into interstellar space, the line extended eerily close to the coordinates of that signal. Not directly upon it, but within 9 degrees close enough that in cosmic terms they could have shared an origin. At first no one dared mention the coincidence aloud, but in private correspondence between researchers the parallel surfaced again and again, each time introduced with caution. Probably nothing, but interesting. The probability of random overlap was estimated at less than 1%. In astrophysics, where space is vast and angles infinite, that is enough to raise eyebrows. Could two anomalies, one of sound, one of matter, trace back to the same region? Skeptics argued that Sagittarius is dense with stars. Any interstellar trajectory might appear to pass through it. But there was more. The velocity vector of 3I Atlas pointed inward, not randomly across the sky, but along a path that intersected the galactic plane at the very latitude of the wow source. Its motion was not arbitrary. It was a return line, a trajectory consistent with something that once moved purposefully outward, now circling back. The notion was unsettling that the faint signal of 1977 and the silent traveller of 2025 might be connected across half a century of human time, a span of seconds in cosmic scale. But what would that mean if 3I Atlas were related to the signal? It would not be a messenger arriving, it would be a relic returning. A remnant of the same unknown event, perhaps the hardware left behind by something that once spoke across light years. In that context, its silence made sense. You do not need to speak twice if your first word still echoes. The coincidence ignited quiet reanalysis of the old WOW data. Modern algorithms ran the 1977 waveform through new pattern recognition systems. What emerged was subtle, but striking. The signal contained harmonic modulation, faint structured intervals in the noise floor suggestive of encoded repetition. The kind that might arise not from a voice but from reflection. Like the echo of a transmission bouncing off something metallic, was 3I Atlas the mirror. The thought bordered on science fiction, yet the numbers refused to let go. Its nickel-rich surface, capable of unusual polarization and reflectivity, could indeed act as a passive transponder, a cosmic shard reflecting radiation rather than emitting it. If some ancient broadcast had once swept across this part of the galaxy, such an object could have answered unintentionally, a silent flash of resonance mistaken for speech. But as always, science demands humility. The link between WOW and Atlas could be no more than the human brain's oldest reflex, the hunger for pattern. the same instinct that sees constellations in chaos. The universe is vast enough that coincidences are inevitable. Yet there is another way to see it. The wow signal, the mirror-like polarization, the perfect timing, the improbable orbit, each a piece of a mosaic too intricate to dismiss. Perhaps these are not coincidences, but symptoms of a greater geometry, one we have only begun to sense. In one of the final briefings before the object vanished into the glare of the sun, an astronomer murmured, "Maybe it didn't come to tell us anything. Maybe it came so we'd remember to listen." That thought lingered, quiet but persistent, because whether the link was real or imagined, the effect was undeniable. The wow signal had taught us to search. 3i Atlas had taught us to doubt. And between those two lessons lay the foundation of all discovery, the courage to admit that sometimes the universe doesn't explain itself. It only invites us to keep asking. And so, as the object faded again into the darkness beyond Mars's orbit, one truth remained for a moment. Two mysteries, a sound and a shadow, had overlapped in both time and memory. Whether by chance or design, they had reminded us that every unanswered question is a bridge between centuries. Perhaps that is the true connection, not between a signal and a comet, but between curiosity and its reflection. Between the echo of 1977 and the observation of 2025, the long unbroken line of human wonder still listening beneath the noise of the stars. If 3i Atlas was a question cast into the dark, then its twin, the comet C2025 K1 known as the Golden Atlas, was the echo that answered. It came not from the deep void between stars, but from the outskirts of our own system. The Oort cloud, that ancient shell of icy debris surrounding the sun like a forgotten halo. Yet despite its familiar origin, K1 Atlas behaved like nothing familiar at all. When it was first discovered, astronomers called it routine, another frozen traveller making its long descent toward the inner solar system. Its orbit was steep, its path predictable, and its perihelion, the closest approach to the sun, perilously tight. At only 31 million miles from the solar furnace, it was expected to die. Models predicted the same fate that befalls all fragile comets: thermal fracture, gravitational strain, disintegration into dust, a death as inevitable as sunrise. But K1 Atlas refused to die. As it curved through the solar heat, instead of collapsing, it flared. Its coma condensed, its nucleus held. The tail shortened rather than expanded. Observers described it as pulling itself inward, resisting the violence that should have torn it apart. By the time it re-emerged from perihelion, it was intact, altered luminous, burning not white like a normal comet, but gold. The colour puzzled everyone. Comets glow according to the gases they release: cyanide blues, carbon reds, oxygen greens. But gold belongs to no natural emission line. In the spectrograms, the expected molecular bands were missing. The signature of carbon compounds, the fingerprints of organic chemistry, had faded almost completely. Instead, the spectrographs captured a smooth continuum of reflected light, punctuated by faint metallic absorption, near 400 nanometers, the mark of iron oxides and silicates heated beyond ordinary sublimation. The comet's surface was no longer a frozen crust, but a vitrified shell, a glass forged by fire. For the first time, scientists began to consider that K1 Atlas had undergone a phase transition never before observed, not destruction, but transformation. The heat of the sun had not erased it, it had rewritten it. Such endurance is rare in cosmic bodies. Most crumble under stress, yielding to thermodynamics. For K1 Atlas to survive something in its structure must have been profoundly different, either unusually cohesive or dynamically adaptive. Its density estimates supported the idea higher than typical comets, closer to the compactness of rocky asteroids. Its reflectivity, meanwhile, increased after perihelion, suggesting the surface had restructured, smoothing itself like metal annealed under heat. When the first images of its golden hue appeared, they stirred both awe and disbelief. It gleamed against the blackness, not blazing like a torch, but shimmering softly as though the sun itself were reflected in liquid metal. Scientists were careful with words. The term survivor replaced comet in some reports. A few began referring to it as the alchemist's body, an object that turned heat into endurance, pressure into permanence. But others saw something deeper. In the archives of interstellar anomalies, K1 Atlas arrived mere months after Through Atlas, sharing not only a name but a narrative, both defying expectations at their perihelion, both producing unnatural spectral behaviours, both discovered by the same early warning network, Atlas. Two phenomena separated by origin, united by defiance. Coincidence perhaps, or repetition. To the cautious, this was a pattern forming objects at the edge of destruction, choosing somehow to remain whole. To the imaginative, it was something more profound, an echo between two realms, as if whatever force or process shaped 3i Atlas was testing itself again closer to home. Could K1 Atlas be natural? Almost certainly. But then again, natural had already begun to lose its meaning. One theory proposed that the comet's golden shell was formed by selective sublimation. Volatile compounds boiled away, leaving behind refractory materials that fused under the sun's heat. Another suggested a self-reinforcing reaction where metallic grains absorbed and redistributed energy, creating a protective layer. Yet even those explanations admitted their limits. For something so fragile to endure that close to the sun requires balance, not just structural strength but dynamic feedback, an equilibrium that adjusts itself under stress, neither collapsing nor resisting too rigidly. In engineering, it's called adaptive tolerance. In nature, it's almost unheard of. And so K1 Atlas survived not as a remnant of what it once was, but as something new. In its survival lay an unsettling symmetry, one interstellar object defying destruction beyond the sun, another local body defying it within. 2 points on opposite sides of possibility, both writing the same word into the sky: endurance. Perhaps that is what the universe was showing us all along, that survival itself is a kind of intelligence written not in thought, but in matter's refusal to yield. Light reveals what mass cannot hide. When C2025 K1 Atlas flared into its golden brilliance, the first assumption was optical illusion, a photometric artifact, perhaps the result of dust scattering or instrument bias. Yet when multiple telescopes across wavelengths from visible to near infrared confirmed the hue, skepticism turned into reverent confusion. Comets are by heritage the dirtiest snowballs in the cosmos. Carbon defines them, the soot of starbirth, the residue of molecular clouds. It's the foundation of cyanide dicarbon and CO bands that give a comet its colour and its voice. Remove carbon and the chemistry collapses, but K1 Atlas was not only deficient in carbon, it was almost barren of it. Spectrographic analysis told the story with brutal precision. The diatomic carbon band at 516 nanometers, normally bright and noisy, was nearly absent. CN and CO, lines the signature heartbeats of cometary spectra, were reduced to faint stuttering traces. When compared with the thousands of comets catalogued over a century of observation, only 2 others had ever shown a similar deficit. Both were from deep-port orbits, and both were classified as chemically exhausted relics that had burned too long in cosmic isolation. But even they retained vestiges of organic compounds. K1 Atlas did not. Its light, pure and metallic, was the colour of reduction, the shine of absence, not abundance. The gold itself was not true metallic gold, of course, but a spectral phenomenon born of the sun reflecting from minerals transfigured by heat. The continuum matched that of iron silicates oxidized under intense radiation, with faint plateaus corresponding to nano-sized inclusions of nickel sulfide particles that could scatter sunlight preferentially into warm wavelengths. The result, a comet that glowed like a slow flame forged not from chemistry, but from physics. Yet the mystery deepened with every hour of observation. After perihelion, K1 Atlas maintained its brightness longer than any predictive model allowed. Its albedo, the fraction of light it reflected, remained anomalously stable, as if its new golden surface was not degrading but hardening. Most comets fade as they recede, their dust dispersing into the solar wind. K1 Atlas did not. It shimmered on, indifferent to distance, refusing to dim. Some astronomers proposed a radical theory. Perhaps K1 Atlas's carbon deficit wasn't a depletion, it was design. The comet, stripped of dark light-absorbing compounds, had become a perfect mirror for survival. Carbon absorbs radiation and accelerates sublimation. Remove it, and the surface becomes radiant resilient. What remains is not ice, but armour. Others looked at it as metaphor, a body shedding its most fragile element to endure. In the furnace of the sun, K1 Atlas had chosen not to perish, but to purify. What died was its chemistry. What lived was its form. There were whispers of comparison. 3i Atlas, nickel-rich, water-poor, engineered for endurance. K1 Atlas, carbon-poor, reflective, reborn through heat. 2 objects from 2 realms, one interstellar and one domestic, both shedding what should define them to become something that should not exist. coincidence or repetition of principle. Some speculated that the same process, natural or otherwise, might link them. Could an ancient mechanism of material evolution unknown to us have sculpted both a thermochemical feedback system operating not within life, but within matter itself? The idea bordered on heresy, yet physics offered a precedent. Under extreme radiation and pressure, matter seeks equilibrium. Perhaps what we call survival is simply the universe's memory atoms remembering how to arrange themselves against entropy. To others it was simpler. The golden hue was beauty, a brief defiant gesture of survival, the sun's light painted upon an object that had refused its own extinction. Beauty that required no meaning, no intelligence, no intention, only persistence. But beauty itself can be data. In the meeting minutes of the European Southern Observatory, one astronomer wrote quietly at the margin of her notes, "We expect destruction. It gives us comfort. Survival terrifies us." Her sentence lingered long after the discussion ended, because what K1 Atlas represented was not merely endurance, it was the quiet humiliation of certainty. Science had built its models upon decay, upon predictable endings. Yet here was a body that redefined survival as transformation, as if the sun itself had forged a monument out of defiance. And when the comet finally moved beyond Mercury's orbit, its golden shimmer did not fade entirely. It dulled, but never died. Even months later, amateur astronomers reported a faint warm reflection like a coal that refused to cool. Some called it the sun's echo. Others more poetically named it the last light of Atlas. Whichever it was, the meaning remained unchanged, somewhere between ice and flame chemistry. And memory, the cosmos had shown that even the simplest materials can learn endurance not by will, but by structure. And in that endurance perhaps lies the blueprint for everything that wishes to outlive its own beginning. In the language of comets, brightness is breath. It is the rhythm of life and death aflare as they awaken or fading as they fall back into darkness. Yet C2025 K1 Atlas broke even that most ancient rhythm. After its close passage to the sun when its ice should have boiled away and its coma dispersed, the comet refused to dim. Its magnitude stabilized near 9, not flickering, not fading, a steady pulse of light that defied decay. To the astronomers tracking it through the nights of November and December, the sight became strangely emotional. The comet that should have perished had become a beacon. Some spoke of it with awe, others with unease, because in that unwavering brightness they sensed not a natural phenomenon but intent. Ordinary comets fade for reasons both simple and inevitable: loss of volatiles, scattering of dust, exhaustion of light. But K1 Atlas seemed to regulate itself as though it had discovered balance. Its brightness fluctuated only within narrow limits, a heartbeat of stability amid chaos. Spectral analysis suggested something even more peculiar. The reflected light retained the same gold-tinted signature weeks after perihelion. No major compositional change, no new emission lines, no signs of fragmentation. A comet, in theory, cannot remain so static. It is a transient creature, always changing, always crumbling. Yet this one persisted like a memory that refused to fade. There were murmurs of comparison again, the mirror from beyond 3i Atlas, and the survivor within K1 Atlas. Two bodies discovered by the same system named by the same chance, behaving against the same expectations, both breaking their own category, both rewriting their own endings. And so, a pattern began to emerge, quiet at first, but impossible to ignore. 3i Atlas. The interstellar traveller brightened without shedding mass. K1 Atlas. The solar wanderer survived where destruction was guaranteed. One became a riddle of motion, the other a riddle of endurance. Their differences were distance. Their symmetry was defiance. The human mind is wired to see meaning in repetition. Once is chance, twice is structure. And if structure exists, it demands interpretation. Among those following both anomalies, a whisper began: the Atlas pattern. A pattern of persistence, the refusal of matter to obey entropy. In both cases, the objects displayed self-limiting behavior as if governed by a feedback loop that adjusted energy and loss. It was as though they shared a code, a rule written not in intention but in physics. Was it coincidence? Could two bodies born in utterly different cradles, one interstellar, one from the Oort, cloud converge upon the same improbable behavior? Could the universe itself, through some unrecognized mechanism, be experimenting with endurance? The idea was heretical and beautiful. that perhaps scattered among the dust and ice of space there exist systems of matter that learn stability, not life, not consciousness, but persistence as principle. When data from the International Asteroid Warning Network arrived in January, the comet's steady brightness was confirmed once more. It had maintained magnitude 9.2 for nearly 70 days, a record of consistency unseen in known cometary history. By now, models had failed completely. Thermodynamics predicted fading, gravitation predicted disintegration. But K1 Atlas lingered a quiet defiance drifting through light. Some speculated that the golden shell might act as a regulator reflecting solar energy precisely enough to maintain equilibrium. Others suggested internal restructuring metallic bonding forming under thermal stress, hardening the nucleus into something that could self-regulate its heat. There were even bolder ideas that the comet had crossed a threshold, the first observed transition between a volatile body and a stable metallic relic, a process that could transform chaos into coherence. And somewhere in the academic papers buried between technical language and error margins, there was always that subtle undercurrent: what if this was not natural at all? What if 3I Atlas and K1 Atlas were not accidents, but echoes the first and second notes of the same melody played across cosmic distance?